Hi, this is Mr. Manley. In this video, we're going to be talking about odd and even identities of trigonometric functions. This is going to be pretty challenging. This situation is that we are talking about all of the trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent, and whether or not the function is odd or even, what that means, and how we use it. For instance, sine is an odd function. Cosine is an even function. Tangent is an odd function. Cosecant is an odd function. Secant is even, and cotangent is odd. Okay, so what does this mean, odd and even? This could be difficult to follow, but what an odd function means is that if the function has coordinates x and y, then it must also have coordinates negative x, negative y. For an even function, if a function has coordinates x and y, then the function must also have coordinates negative x and y. Just take a look at what that looks like visually. The sine function, and we're kind of getting ahead of ourselves here, which is maybe why you find this difficult, but the sine function, if I looked at its graph, it looks like this. That's what the sine function looks like. Let me write that down, sine. The cosine function looks like this. Like that. Now, what did we say? We said the sine function is odd and the cosine function is even. And we said that for an odd function, for each xy, it's also going to have negative x, negative y. And for the even function, for each xy, it's also going to have negative xy. So let's see if we can make a little bit of sense of that and see how that works. That means if I had this point over here on the graph of the function, and if that were point x, y, then I would also be able to find negative x, negative y. So if I look at that xy, I'm going over x and up y. And then that means also on the graph of the function, I would have to be able to go the opposite of x and the opposite of that y and find a point that is part of the graph of the function. And that will work for any point on the function. I just take another random point here and say, okay, I'm going to take this point out here. Now, what's the x and y for that point? The x goes here, the y goes here. So I have to be able to do the opposite of that and hit the graph. So I'm going to go the opposite direction, x, opposite direction, y, and I'm going to hit the graph of the function. So for every xy, the function will also have negative x, negative y. For an even function, for any point, see, I take a point here, and to get to that point, I go over x and up y. That would mean that I also have to be able to do, here, look, the opposite of x and up y. So if I do the opposite of x and up y, you see that I hit the graph of the function. I do have that point on the graph of the function. That's a little background on even and odd functions and why sine is even and cosine is odd. Now, how well you need to follow that and understand that, maybe not so much in order to be able to do the problem. Let's go back and see. So I do need this information. I do need to know whether the function is, whether the trig value is even or odd. Now that you can kind of memorize for the first part of the problem. So if I look at the first part of the problem here, it says for each function below, indicate whether it's odd, even, or neither. Well, for all of our functions, it's either going to be odd or even. We're not going to have any neithers. So for f of x is equal to sine x, I've told you over here that it is odd. So I'll mark that. And then for secant x, I've told you over here that it is even. So we'll mark that. So that part should be easy because you'll always be able to answer the first part here if you know this table, shall we call it. So if you think that's easy to memorize a table, then that first part is easy. If you think it's difficult to memorize a table, then that part's still going to be hard. Okay, the second part here, let's take a look. I'm being asked to evaluate. I'm actually not being asked to evaluate. You're going to be given choices here. And I can't do the drop-down menu the way that my video is designed here, and not actually being on ALEKS. I just have a copy of something, a copy of a page from ALEKS. So I don't have the drop-down menu. Let's look at it if I didn't have the drop-down menu, though, and just talk about it a little bit. That I've got the sine. What does the sine of negative 67 equal? Well, I've said over here that the sine function is an odd function, which means that given some x and some y, I'm going to have the opposite of x and the opposite of y. So let's think about that for sine of negative 67 degrees. Let's call the output of the sine of negative 67 degrees y. So there's going to be some output y. Now what I've said up here for an odd function, up here in the upper right, is that for every xy, it also has negative x, negative y. So for every point xy, it's also going to have the opposite of the x and the opposite of the y. So look what I'm going to do here. So that means that for the sine of 67 degrees, which is the opposite of negative 67, I'm going to have the opposite of y. So I had an xy, I had an x, and I had a y, and I said, well, that means that I also have to have the opposite of x and the opposite of y. Probably pretty challenging for you to follow there. Now, what's going to be in this drop-down menu here, where you're going to be able to choose one, even gets a little bit more confusing, is that if I take this guy here and I move the negative sign, right? So I'm going to, basically I'm going to divide both sides by -1. Divide by -1, and then what will I have? I will have the negative sine of 67 degrees is equal to y. I think if you're going to want to be able to do this, you're probably going to have to rewatch what I just did there a couple of times. Almost everybody would have to really slow it down and try and follow what I'm doing there. Because there's one more step. And the one more step is I'm going to take out this middle part here. And you're going to have to just say that taking out the middle step is no big deal, because it's just this bottom step divided by -1. And now I can see that y equals this. and y equals this. So one of the choices in the drop-down menu is going to be that sine of negative 67 is equal to negative sine of 67 degrees. Now, you don't have to go through that process every single time that I did there. Actually, you're just going to kind of memorize that for the sine of anything, it doesn't matter what the angle is, positive or negative, the sine for the sine of theta, that's going to be equal to the opposite of the sine of negative theta. Kind of ran out of room there. Let me try and fit that in a little better. It's going to be equal to the opposite of the sine of the opposite of theta. That's a way of seeing how an odd function affects a possible equality involving sine. Now let's take cosine theta, which is an even function, and based upon what we're saying about even functions over here, that for every xy, we also have negative xy. The statement that we can make about cosine is that for every cosine theta, that's going to be equal to the cosine of negative theta. And then I could do a comparable statement for every one of the trigonometric functions based upon whether it's odd or even. I'll just take one or two more over here, probably just one more. Like if I take tangent theta, since that's odd, that's going to be tangent theta is equal to the opposite of the tangent of negative theta. So it's probably going to take you some time and some practice to get these, but that is how even and odd, what even and odd functions are and how they work with the trigonometric functions.